This video will cover the solution guide to problem 6 from chapter 8. The mass of a regulation tennis ball is 57 grams. The tests have shown that the ball is in contact with the tennis racket for 30 milliseconds. We shall assume a 30 millisecond contact time. The fastest known served tennis ball was served by Big Bill Tilden in 1931, and its speed was measured to be 73 meters per second. What impulse and what force did Big Bill exert on the tennis ball in his record serve? If Big Bill's opponent returned his serve with a speed of 55 meters per second, what force and what impulse did he exert on the ball, assuming only horizontal motion? We have two definitions for the impulse. The first one is that the impulse is the integral of the force with respect to time. In other words, impulse is the area under the force curve on a force versus time plot. In this particular case, because the force being applied is assumed to be a constant and only acting in the x direction, we can pull the force out of the integral, and what we find is that impulse can be calculated in this problem by multiplying the force by the time over which it was applied. Another definition we have is that impulse is equal to the change in momentum. Because the mass is constant, impulse can be defined as the mass multiplied by the change in velocity. In part A, when Bill sets up his serve, we are going to assume that the ball is not moving at all in the x direction, so the ball's initial velocity will be 0. After the racket exerts its force, the ball leaves with a velocity of 73 meters per second in the positive direction. We are not given the force exerted on the ball, so in order to calculate the impulse, we will have to use our second definition. Impulse equals the change in momentum. Subbing in our values for the mass and the final and initial velocities, we find that the ball experienced an impulse of 4.16 newton seconds. Now that we have the impulse, we can use the first definition to find the force exerted on the ball. Rearranging the impulse equation to solve for the force and substituting in the values for the impulse and the time interval in which the force acted, we find that the ball felt a force of 139 newtons. In part B, the ball is already traveling towards the opponent at 73 meters per second. The opponent then swings at the ball and sends it back towards Bill at 55 meters per second. The only thing that has changed in part B are the initial and final velocities. The procedure will be the exact same. Impulse equals the change in momentum, so, subbing in the values for the mass and the final and initial velocities, we see that the magnitude of the impulse increased to 7.30 newton seconds in the negative direction. Then, using the first definition for impulse and rearranging for the force, we find that the opponent had to exert a force of 243 newtons in the negative direction in order to send the ball back to Bill at 55 meters per second.